Okay, so we just now really need to get into some more of the structure of the atom. And so if we look at the structure of the atom and kind of some of the forerunners, again, we're looking at some scientists, some people that were involved in the development of the structure of the atom. First, J.J. Thomson, again, you notice early 1900s, late 1800s, J.J. Thomson discovered the electron. And he noticed that an electron has a negative charge. He used a cathode ray tube, and basically what a cathode ray tube does is it shoots out particles, okay, that are charged, and they can be bent or attracted, however you may want to think of, either attracted or repelled, depending on what you are bringing up next to it. So let's say we're going to shoot out some negative charged particles, and I have a positively charged area on the top area of the tube. Well, those particles, obviously, because they're negatively charged, are going to be attracted to the positive end, okay? And the opposite for if it's a positively charged particle being shot off, it would be repelled from the positive end. Cathode ray tube really was used up into, and still is, but used as our TVs quite a few years back. I say quite a few now, we get all the plasma and the LCDs, etc. But basically a CRT is cathode ray tube, and that's kind of how it works. It deals with charged particles. So that was J.J. Thomson and the discovery of the electron. Eugene Goldstein, in again about the same time, evidence for positively charged particles, or protons. Protons have positively charged particles. Obviously, if there was something negative, there must have been something positive, because atoms are neutral, so there needed to be, if there's one, then certainly we'd have to have one that counteracts the other. Second and lastly, James Chadwick. James Chadwick discovered the existence, or confirmed the existence, of a neutral particle, which of course is the neutron. So we get our protons, electrons, neutrons, basically the main building blocks of atoms. So if I look at my next slide, kind of, and just create like a little box here, I'm looking at the structure of the atom, and I like this little chart. This little chart kind of describes a little bit about the atom. And as you can see here, we have our proton, which is located in the nucleus, as is the neutron, right? The protons and the neutrons are both located in the nucleus. And they have, and here if we're looking now at our charge, the proton has a positive charge. So the proton has a positive charge. I see my P right there. P for proton, for positive charge. So that's your proton and its positive charge. Of course, a neutron, just as the name kind of describes, is also neutral. So a neutron is neutral, which makes complete sense, I hope. Now, obviously, the third particle, the electron is located around the nucleus. I don't want to talk too much about it right now. We're going to get into greater detail. Some of us maybe in the past have seen these little drawings, you know, whether it's the nucleus, and then we have our kind of electrons moving around the nucleus. We don't want to think of them as orbits. They're not like an orbit, like a planet around the sun, but we'll describe more of how they are located. Sometimes people think clouds around, but again, it's a little different than that, and we're going to describe that as we move along. So our location for our three particles, obviously the protons and neutrons are located in the nucleus, the electrons are around the nucleus. If we look at the charges, notice your protons are positive, your electrons are negative, and your neutrons are neutral. Now they all have mass, okay? They all have mass, and this mass is in grams. You can see here, grams. It's a ridiculously small mass, 1.675 times 10 to the negative 24. So again, if you're writing that number, 1.675, of course my point is right here, to write that negative 24 for an exponent, that means that the number is less than 1. 1, 2, 3, 4, 5, 6, 7, 8. All these zeros would be in front of 1.675, okay? ridiculously small, which makes sense because we just saw how many atoms are in something the size of a penny, something to the times 10 to the 22nd. So a ridiculously large amount of them, obviously, then therefore the things that make up an atom must be ridiculously light. So that's how much grams each of are. And I want you to really notice that the proton and the neutron are pretty much the exact same. And when you talk about 1.675 versus 1.673, after having 23 zeros in front of it and then having just that little number, it's considered the same mass, exactly the same. And so what we've done is, and what scientists have done, has come up with this mass, rather than in grams, which is such a ridiculously small number, we come up with AMU. AMU stands for atomic mass unit. And it's a made up mass. It's not something that we can mass, but basically a made up mass that describes the mass of a proton. So notice that the in AMUs, the protons and neutrons are the same. Now the reason that an electron is 0 for an AMU, which it does have mass, electrons certainly do have mass, but we consider them negligible mass, because notice the exponent here. We got 9.109, which is larger than, of course, 1.673, but 9.109 times 10 to the negative 28. And since we're dealing with negative 28, and again, I can kind of put a spotlight right on that here. Let me move this around. Whoops. Whoops. Let me get out of my spotlight. Forget the spotlight for now. Since it's times 10 to the negative 28, then you're dealing with 4 more moves of your decimal, and so it is so much smaller. So protons have a mass of 1, neutrons have a mass of 1, and electrons, we're going to say, have a mass of 0. They do have a mass, it is important to remember, but they're negligible. So when we talk about the mass of an atom, we ignore the electrons. It's just the protons plus the neutrons equals the mass of the atom.